All right, ladies and gents, welcome back to another episode of How to Algebra. In this particular video, this is part 1 of 3. We're going to use an acronym, R.A.T.E.Y, to graph rational functions. All R.A.T.E.Y is an acronym that helps us collect our thoughts and information about where the graph crosses the x-axis, where it crosses the y-axis, if there's a vertical asymptote, if there's a horizontal asymptote, and then what the branches, right, the pieces of the function, what they do towards the ends of the asymptotes, right? If it's the vertical asymptotes, if they come together, if they go in opposite directions, and then the horizontal asymptotes, as they approach infinity, right? As x approaches infinity, what they do. So without further ado, let's get it. All right. R.A.T.E.Y part 1. So as I work through the examples, I'm going to explain what I am looking for and how to analyze what the information is telling us. So the R, I'm looking for the roots. Where does it cross the x-axis, right? In other words, the x-intercepts. To do this, I need to set the top equal to 0. All right, so when I set the top equal to 0, right, I don't care about what the bottom is in this step. So here, it's nice because the top is equal to 0. It's just x. So that means x is equal to 0 because I set the top equal to 0. So at x equals 0, that's where the graph is going to cross, right? It has to cross because it's a root. The second, and it only crosses in one spot, right? It doesn't have multiple roots. It only has the one. All right. Second part, I need to find the asymptotes. Specifically, the vertical asymptotes. And I do this by setting the bottom equal to 0. All right, so the bottom, x plus 3 equals 0. Again, regardless of what the top is, right? In these two steps, I'm setting the top and the bottom equal to 0, independent of one another. Like, I don't care about the other one, right? I don't care about the top when I'm focused on the bottom. I don't care about the bottom when I'm focused on the top, right? Because they tell me two different pieces of information. So this is saying that x equals -3. So at x equals -3, there's a vertical asymptote that the graph will approach and never cross, obviously. Okay. The third one, so we call this, like, typically there's in some formats, call it t squared. Because the idea is that we're looking for a squared factor. All right, so when we're looking for the squared factor, for a squared factor, we're looking for one in the top, and we're looking for one in the bottom. All right, so here, because it's already factored, right? I can't factor it anymore. It's already factored. There's not a squared factor in top. Also, furthermore, there is not a squared factor in the bottom. So let's just talk quickly about what if there were. All right, so And by squared factor, I mean this, right? So I'll modify this so you can kind of get an idea of what it is I'm talking about. Right, that would be a squared factor on top. This would be a squared factor in the bottom, right? It doesn't have either one of these things. So if there were a squared factor in the numerator, the top, think of it as, so talking about the letter T, right? So the word is tangency, right? Tangent, meaning it would touch at exactly one spot. So the graph would not cross at that x value if there was a squared value on top, right? I prefer the word bounce. So it would bounce at that x value if there was a x squared or a squared factor in the numerator. In this case, there isn't one, so I'm not worried about that at the moment. Okay, completely separate of that thought, right? Completely different train of thought. If there's a squared factor in the denominator, right, in the bottom, if there were, then at that asymptote, vertical asymptote, the graphs would approach the asymptote together, right? Like they would come together. So the T word would be togetherness. If there was a squared factor in the bottom, but since there's not, then that means that at the asymptotes, the graphs are going to be opposite of each other. Meaning, if the graph goes up this direction, then the other side, the graph has to go down. Right? That's strictly because there are none in the bottom. There are no squared factors in the denominator. So at the asymptotes, the branches, right, that's what we call the lines of a rational graph. The branches are going to be opposite of each other. So this is going to mean, so they're not together, right? So this means that because it's none, they're going to go opposite. Had this been yes, there is a squared term in the bottom, then they would be together. All right. Then we look at E for end behavior. So end behavior is talking about as the graph goes towards infinity, right? As x goes towards infinity, what is it approaching? All right, so here, the end behavior, you have to think horizontal asymptote. All right, and to do that, you have to compare the largest degree in the numerator against the largest degree in the denominator. So what am I saying? I'm saying that if we analyze the rational function, the largest degree in the numerator, so the degree is the power that is on the variable. Well, there's only one variable, and that single variable has the power of 1, right? Because there's nothing there. It's implied that it's a 1. All right, so the degree of the numerator is 1. Looking at the bottom, the denominator, there's only one x variable, and it also has a power of 1. So the degree in the numerator is equal to the degree in the denominator. We call this being balanced. All right, when it's balanced, we then have to compare the ratio of the coefficients that are on the variable. So again, there's nothing in front of the x, so it's understood that there's a 1 there in both x cases. So 1 on top, 1 on bottom, right? There's a 1 in front of the x on the top, there's a 1 in front of the x on the bottom. So 1 over 1. This is going to, 1 over 1 is just 1. So it's going to be 1. Y equals 1. That's where the horizontal asymptote is going to be, at y equals 1, positive 1. So if the degree in top, say, is bigger than the degree on bottom, we consider this to be top heavy. So in a top heavy case, which we're not covering in this particular video, it'll be the part 2 video, to figure out where the horizontal asymptote is going to be, you have to use long division, which we'll cover that later. So you use long division or synthetic division, but long division to figure out where the horizontal asymptote is going to be. And we'll discuss that later. The third case is if the bottom degree is larger than the top degree. In this case, it's bottom heavy, right? Because there's only 3 possible scenarios. In the bottom heavy case, it's always y equals 0. It's always y equals 0. The horizontal asymptote is always y equals 0. All right. But that's not the case right now. But that's definitely going to come up here in a moment. So in our case, right now, it's balanced and y is equal to 0. That's the horizontal asymptote. So that means, right, that out towards infinity, right, as x goes towards infinity, the graph is going to get closer and closer and closer to the asymptote, but it'll never cross. All right. There will be times when there are cases when closer to the origin, right, closer to the origin, there are cases where the graph crosses the horizontal asymptote specifically, and only the horizontal asymptote. And that's because we are really concerned about the end behavior. Because there are some cases where the graph may cross the horizontal asymptote and then come back down and then approach it, but never cross it again, right? Because we're looking at that end behavior. We're not worried about closer to the origin. It's strictly the end behavior. So what is the graph doing as x is getting very, very large, right, towards infinity? It's approaching some number, which this leads into a topic that'll come out in pre-cal. This idea, and then on into calculus, the idea of a limit, right? Like the limit, what number is the graph approaching as x is getting really, really large, which we'll cover that much later. But just know that you've been taught that the graphs don't ever cross asymptotes, which is 100% the case for vertical asymptotes. And then the horizontal asymptote, it won't cross at the ends, like towards infinity, but there may be cases when closer to the origin, the graph has to cross and then continue towards infinity and then approach the asymptote. So just know that. All right. So y equals 1. That's the horizontal asymptote. So abbreviation for that, we use HA. All right. Last is the y-intercept. So here we have to think about when does it cross the y-axis? And that is when x is equal to 0. Specifically, x being 0. Not the top or the bottom, but x in general. So when x is 0, right, because we're talking about a point. When x is 0, what is y? Well, in this case, this is going to be 0 over 0 plus 3, which is basically 0 over 3. And 0 over anything is 0. Right? 0 over anything other than 0, it's 0. So in this case, 0, 0 is the y-axis, y-intercept. So now, putting this all together, right? Because really, R.A.T.E.Y, all the little checklists that we went through, what does it really tell us? It tells us the asymptotes, vertical and horizontal, and then it gives us where it crosses the x and the y-axis. And then it gives us the behavior at the ends of the asymptotes, whether it's vertical or it's horizontal. So first off, I know that based on the roots and the y-intercepts, it has to cross the origin. So the one branch is going to look like this, right? Towards the ends of the asymptote, that's what it's going to approach and never cross, right? The red one and the blue, the vertical and the horizontal, right? And I know it has to cross at the origin. All right, so we need a second branch. So the second branch, first off, will never look like this, right? For a couple of different reasons. One reason, there's only one y-intercept. So how is it going to cross the y-axis twice? It won't. There's only one. So this can't be the case. Not only that, but this is a function and it fails the vertical line test, right? Because the vertical line test, if you remember, if the graph crosses the vertical line twice, then it's not a function. So this can't be the case, right? This, and not only that, but the graphs will never, the branches will never come together left or right. So it can't go there. My only other options are here in the upper left quadrant or here. So again, for the bottom left quadrant to work or to be the branch, it would have to cross the x-axis. But again, we know that's not true because the x-intercept, the roots, there's only one. So it can't cross. So specifically, it has to be this upper right. Okay. At the end of the day, right, if you can't logically think your way through, right, if you can't think your way through where the branch needs to be, don't forget that you know how to plot points, right? Because at the end of the day, it's still a graph, right? It's going to take an input and it's going to give you an output. So if I were to pick, say, something to the left of -3, right? So -4. If x is equal to -4, when I plug -4 into the function, I'm going to get -4 over -4 plus 3, which is basically negative 4 over negative 1, which is going to be a positive 4. So when x is negative 4, y is going to be positive 4. So 1, 2, 3, 4. So now we have a point that we know is defined, well defined by the function. So before I even drew the branch, we could find this point, and I know that that's where the branch has to be. And not only that, but notice the ends of the branches, they have to tend towards the asymptote, whether it's the vertical asymptote or it's the horizontal asymptote, but it has to tend towards that. And not only that, but going back to our checklist, because of the second, or the third rather, the t squared, right? That bottom not being a squared factor tells us that the branches are going to go in the opposite directions. So if I know for a fact that one branch goes down, well, then the other branch must go up because it has to go in the opposite direction. So there's like so many different clues that are hinting at what the graph should look like. You just got to be able to see it, right? So this one took some time because I was explaining all of the things, but let's see if we can go slightly faster. So hopefully you have some good notes here, because now instead of writing out what they are, I'm just going to write out how it should look. So first things first, set the top equal to 0. So 5 is equal to 0. Right away, we see that something's not right. So when the top is a number, right, 5 is equal to 0. How is that true, right? No, 5 is equal to 5 and only 5. 5 can't be 0. So this tells me that there is no x-intercept, right? There is no x-intercept. It never crosses the x-axis, ever, nowhere. So that's the first part. Second part, set the bottom equal to 0. All right, we have a quadratic, so I'm going to try to factor this. So two numbers that make 4 that add up to negative 4. So negative 2 and negative 2. So notice there are two x minus 2 factors. So x minus 2 squared. This is what I mean by, this is going to come up in the t part looking for the square, but look, this is a squared factor. So this is saying that there's a vertical asymptote. There's a vertical asymptote at x equals 2. Right, x equals 2. So positive 1, positive 2. So here's 2. There's a vertical asymptote at x equals 2. All right, the next one, the t squared. So top, bottom. So I'm looking at just the top where there's a 5. There is no squared factor in the numerator. So none. Now, looking at the bottom. Yes, there is. Right, there's a squared factor in the bottom. So let's kind of clear something up. Just because there's a squared in the denominator doesn't mean that there's a squared factor in the denominator, right? I had to factor the bottom first, only to see that, hey, there are two x minus 2s. That means that it's squared, right? So the x squared minus 4x plus 4, that's not grounds to say, hey, there's a square in the bottom, right? There's not a square factor in the bottom. There's a square in the bottom because there's a quadratic in the bottom, the denominator that is, but there's no square factor. Not until you factor the bottom get it fully factored, and then you can see if there's any repeating roots, basically. So this yes, this is telling me something very specific. This is saying that at the vertical asymptotes, right, at the vertical asymptotes, the branches will come together. So I'm saying that they're going to come together like this, or they're going to come together like this. These are only two options. That's what I mean by coming together, right? They're going to come together towards the ends of the asymptote. So it's going to be one or the other. We'll get to that in a second. The end behavior, right, towards the horizontal asymptote, we have to analyze the actual rational function, right? So we need to compare the top to the bottom, the degree in the top to the degree in the bottom. Is it balanced, top heavy, or bottom heavy? Well, there's an x squared in the bottom and there's no x's in the top. So this is considered bottom heavy. I guess I could have wrote that down here. Right, this is bottom heavy. And right away, when we have a bottom heavy situation, the horizontal asymptote is at y equals 0 every time. So y equals 0. That means that towards infinity, the branches will approach y equals 0, but it'll never cross. All right, and last but not least, the y-intercept. We got to set x equal to 0. So 0, 0 plus 4. This is going to be 5 over 4, which is basically 1.25, right? Because this is when x is 0. All right, so positive 1, positive 2, so 1.25. All right, so putting it all together. So that first branch is always going to be pretty obvious, only because it crosses the y-axis. So I know that towards infinity, right, towards the end, the graph is really close to the asymptote. It has to cross the y-axis, then go towards the other vertical asymptote. Okay. My only other option, I have two, right, because down here is not an option, because they'll never come together horizontally. So my other options are top right or bottom right. You probably already know the answer, but based on the t-squared analysis, right, we know that the branches will, in fact, come together. So that means they're going to go in the same direction on that vertical asymptote, right? On the vertical asymptote, they have to go in the same direction. Or let's say you missed that part, right? If you missed that part, then simply pick a number that is right of 2. Right? What's right of 2? The very next number in order is 3. So at x equals 3, depending on what the output is, right, y could either be a positive number, which would put it above the x-axis, or it'll be a negative number below the x-axis. So in this case, we have 5 over 3 squared, which is 9, minus 4 times 3, which is 12, plus 4. So 9 and 4 is 13. 13 minus 12 is 1. So we have 5 over 1, which is basically 5. So when x is 3, y is going to be positive 5. That's going to put it for sure above the x-axis. All right. So some people, I don't know, can logically think their way through where the branches should be, and then others may want to just brute force and just immediately pick numbers and then just start figuring out where the dots are and then go from there. Whichever way is completely up to you. All right. Number 3. We'll set the top equal to 0, right? Because this will tell us our roots. So we have one root at x equals positive 3. So I know that one of the branches is going to cross at positive 3. So right away, like right now, you can start thinking, okay, it has to cross at 3. Is it going to cross like this? Is it going to cross like this? Because really, those are the only, I don't say the only option, but it has to cross some way, right? So you can start thinking ahead. How is it going to cross, right? All right, the asymptote, set the bottom equal to 0. So the vertical asymptote is going to be at x equals negative 2. So at x equals negative 2, there's a vertical asymptote that the graph will not cross. All right. Is there a squared factor in the top? No. Is there a squared factor in the bottom? No. So right away, this is telling me that the branches are going to be opposite of each other. Right, the branches, the ends of the branches are going to be opposite of each other. Right, one's going to go up while the other one's going to go down, or vice versa. Right, one side's going to go up while the other side's going to go down. Right, those are my only two options, which we'll figure that out here in a second. In behavior, right, horizontal asymptote, we have to compare what is the degree in the numerator. Well, it's 1, right, because the biggest power is 1. What's the degree in the denominator? Oh, it's also 1. So now, because it's balanced, right, I have to look at the ratio of the coefficients. Well, in this case, it's 1 over 1, which is saying y equals 1. That's the horizontal asymptote at y equals 1. All right, so hopefully you can kind of see where this is about to go. But the last step in the process is the y-intercept. So we got to let x equal 0. So when x is equal to 0, we're going to get 0 over minus 3 over 0 plus 2, which is negative 3 over 2, which is basically negative 1.5. So negative 1.5. That's the y-intercept. All right, so that first branch, it's got to be obvious at this point, right? There's 2 points that must live on the graph. So it's got to cross the y-axis, it's got to cross the x-axis, and then head towards the asymptote. All right, now the next branch, right? We know that it has to be opposite. It has to. And it can't be on the same side of the asymptote. So it's got to be up in this direction. And then it's got to go towards infinity in this direction. And if you don't, if you don't like that, then you can plug in negative 3 and then see what happens. So when x is equal to negative 3, y is going to be negative 3 minus 3 over negative 3 plus 2, which is negative 6 over -1, which is +6. So 2, 3, 4, 5, 6. So -3, +6. Right, and there the graph has to be. It has to be. All right. Number 4, set the top equal to 0. 1 equals 0. That's crazy talk. So there are no x-intercepts. Set the bottom equal to 0. So 2x equals 0. 2 times something is 0. X has to be 0. So there is a vertical asymptote at x equals 0. So at x equals 0, there's a vertical asymptote. All right. Is there a square? Is there a square factor in the numerator? Nope. Is there a square factor in the bottom, the denominator? Again, no. So right away, this tells me opposite. Like immediately, the moment it's no, opposite directions. All right, end behavior, horizontal asymptote is going to be at the comparison of the top and the bottom, right? The degree and the top, degree and the bottom. So there's an x in the bottom, but there's no x in the top. So that means this is bottom heavy, right? Because the degree in the bottom is 1, the degree in the top is basically 0 because there is no x, right? So definitely bottom heavy. Bottom heavy situation is going to be y equals 0. That's the horizontal asymptote at y equals 0. Every time it's bottom heavy. Okay. Last part is the y-intercept. Where is the y-intercept? So we have to let x equals 0. Okay. When I plug in 0, we get -1 over 2x, which is basically 2 times 0, which is basically -1 over 0. And anything divided by 0, like when 0 is in the bottom, this is bad, right? Is undefined. So there is no y-intercept, right? There is no y-intercept. That's what this is telling me. No y-intercept. Okay, so you may be saying, okay, well, where do I put my branch at? Well, don't forget that we know how to graph, right? Technically, right? If you know what the parent function looks like, right? Parent function is going to look something like this. And because this is negative, I know it's going to rotate. But let's just say I don't know that, right? Let's say I don't know that. Well, then let's just pick a number left or right of 0 for x. So if we pick to the right, which would be 1, when x is 1, this is going to be -1 over 2 times 1, which is basically -1/2. So when x is 1, y is going to be -1/2. So right there. And right away our answers, or our question is answered, right? The branch has to be in the bottom. It has to be. And then we know that because of this no right here, it's going to be opposite, right? The other branch has to be in the opposite direction on that vertical asymptote. So it's got to come from this direction, or head towards this direction rather. you want, you could plug in -1, right? And this would have been x equals -1, and then y would be 2 times -1, which would just be positive 1/2. So at 1, we would be positive 1/2, and then we'd have to amend our graph. It would look something like that. Right, this is -1, this is -1, positive 1, positive 1. Okay. Okay. Let's stick to the script, right? Regardless of what they throw at us, let's just stick to what we're doing. Right, set the top equal to 0. Okay, 2 is equal to 0. It's nonsense. There are no x-intercepts, right? There's no roots. There are no roots. Bottom equal to 0. This one's interesting. This one's interesting because we subtract 1, we subtract 1. So we're going to get x squared is equal to -1. Square root, and oh look, x is going to be equal to a square root of a negative number, which in our case, right, this isn't, like, we don't worry about complex numbers and imaginary numbers, right? This is an imaginary number. So this is none, right? There's no vertical asymptote. Or there's no vertical asymptote because you can't take the square root of a negative number. Like, we only are concerned with real numbers, not complex numbers or imaginary numbers for that matter. So there's no vertical asymptote and there's no roots. Okay, so far this is already looking crazy. Is there a square factor in the numerator? No, there isn't. Is there a square factor in the denominator? So be careful here. There is a square here, but I don't care about that square. Is there a square factor? That's the question. Is there a square factor? Well, I can't factor x squared plus 1. It doesn't factor anymore. So, no, there isn't. So, as before, right, this is telling me something about the graph's behavior at the vertical asymptote. Oh, but we don't have a vertical asymptote. So let's just see what happens. All right. In behavior, we need a horizontal asymptote. So we have to compare the degree in the denominator versus the degree in the numerator. Degree in the bottom is 2. Degree in the numerator is basically 0 because there is no x in the numerator. So this is definitely bottom heavy. So y equals 0 is going to be the horizontal asymptote. Y equals 0. So y is equal to 0. Okay, so the y-intercept, right, where does it cross the y-axis? We let x equal 0. So in this case, 2 over 0, right? 0 squared is 0 plus 1. So this is going to be 2. So the point 0, 2 is defined on this graph. So positive 1, positive 2. Okay, so let's think about this for just a second. I know that the graph has to cross at 2, y equals 2. Not only do I know that out towards infinity, the graph has to approach the horizontal asymptote, y equals 0. Okay, so we kind of can fill in the dots, right? So it has like this little hill. So it's going to come up and kind of level off. So if you think about it, if you plug in numbers left and right, -1 and 1. So at 1, we're going to get 2 over 1 plus 1, which is basically 2 over 2, which is basically 1. So we can actually amend our graph. Then if you plug in +1, if you plug in +1, or we did plug in +1, plug in -1. Okay, what's going on here? So at +1, 1, 1. If we plug in -1, right, at x equals -1, -1 squared is basically +1 plus 1. So again, we're going to get 1 again. So at -1, we're going to get 1. So it's going to look like this. It's going to cross at 2, come down towards 1, and then just start heading towards the asymptote. Horizontal asymptote, that is. It's kind of an interesting shape given what the parent function looks like, right? Kind of crazy. So yeah, I think the key here would be the graphing part, right? Whenever it looks crazy, whenever the graph looks crazy, just start plotting points, and then that'll hint to you on where the branch should be. Just remember that towards the ends of the asymptotes, that's where the graph, the branches should head towards. All right, here's the last one. So here we have 2x is equal to 0. So x-intercept is going to be when x is 0. So at x equals 0, the graph is going to cross, right? It's got to cross somehow. It's got to cross somehow. We have a vertical asymptote when the denominator is 0. So factor in this, two numbers that multiply to make -12 that add up to -4. So -6, +2. This means there's vertical asymptotes at x equals 6 and also x equals -2. So this one's starting to look crazy as well, because now we have 2 vertical asymptotes as opposed to 1. All right. We look and see if there's any squared factors in the top. So there's not. And then we look to see if there's any squared factors in the bottom. Again, no. So immediately, right now, that's telling me that at every vertical asymptote, the branches will be opposite of each other. That's basically going to be key in trying to figure out what this thing looks like, because right now it looks crazy. All right, the end behavior, the horizontal asymptote, is going to be at the comparison of, we have to compare the top to the bottom, the degree. So degree in top is 1, degree in the bottom is 2. So this is definitely bottom heavy. So the horizontal asymptote is going to be at y equals 0 because it's bottom heavy. So y equals 0. Y equals 0. All right, and last but not least, it has to cross the y-axis. Based on the picture, I can tell you where it's going to cross, but let's just see. We have to let x equal 0. So 2 times 0 is 0. Right away, the fraction, the top is 0, so it's going to be 0, unless the bottom's undefined, but in this case, it's going to be 0 minus 12. Basically, it's 0. So the point is 0, 0, which again, we already have that kind of marked out. Okay, we've gone through all of our lists, and we actually have enough to figure out how this thing is going to look. Actually, we don't have enough to figure out how it's going to look. Does it cross the blue way or does it cross the red way? And the only way to figure this out is by graphing. Right, I need to plug in an x value, so I'm going to plug in 1. When x is 1, right? If the value of y is positive, then I know that the graph will be up here, and it'll be the red line. Now, if I plug in 1 and I get a negative value, then I know that the graph will be below the x-axis, and it'll be the blue line. So let's see. When x is 1, we're going to get 2 times 1 over 1 squared minus 4 times 1 minus 12. So this is going to be 2 over 1 minus 13. No, 1 minus 16. Negative 16, right? 1 minus 16, right? Because negative 4 and negative 12 is negative 16. So 1 minus 16, which is basically 2 minus 15. So a negative value. So right away, I know that when x is 1, y is going to be negative 2/15, right? Somewhere like in here. So what that means to me is that I know that the graph, the branch, will be towards, like it's got to be towards infinity, right? Close to the asymptote. It's got to come down, and at some point it has to cross at 0, 0. Then it's got to go through the 2 negative 15ths. But not only does it have to do that, it still has to tend towards the vertical asymptote, going down. All right, bro, what's up? So I know it has to tend towards the vertical asymptotes. All right. Another branch, or not only another branch, but because of the t squared information, right, it has to be, the branches have to be opposite, right? On that vertical asymptote, they have to be opposite. So that means immediately it's got to be down in this direction, right? They can't come together because there was no squared factor. And then the horizontal asymptote, it has to tend towards as well. All right. Now the fact that there's 2 vertical asymptotes, the second vertical asymptote has to follow suit, right? It cannot go down this way because, again, it has to be opposite, right? It has to be. That's like the rule. So there's only one place it can be. It would have to start up here and then come down. So this one already looks crazy, right? It looks crazy, but you know, that's what it is, right? Now, if you couldn't think your way through that, you can always pick x equals negative 3 and see if the value is going to be positive or negative, right? The y value. And it's going to be negative, I promise you, because, again, the graph is going to be below the x-axis. And then choose something to the right of 6, like 7 or 8, or choose a nice number like 10. 10's easy to deal with. And you'll see that it would be a positive value, so it would be above the x-axis. All right. In the next video, we'll go over part 2, where we'll look at the top-heavy cases. So I'll catch you in the next video.